our changes. I think mainly what I want to do, I decided for some reason that this was a good time. We're going to remove props dot in all the places and just reference. Wait, where are we at? Okay. Sure. Think about how all the characters will save. That's important. It's not. Right. But hey, I'm here. I'm changing things. Let's just do it. So let's add status lambda. Let's call it task status lambda. Actually. There we go. All right. Apparently we don't need that. What are we missing here? We'll just add everything that's in props, and then we'll remove whatever's not being used. So, media distribution isn't being used? It is. Oh, but in state machine, we're just passing in props. Right? I see. Let's not do that. Let's how many things? Well, I broke all the things, didn't I? Okay, so we're just gonna change let's see. We're gonna keep this being an object. We're going to have a definition. What are the things we need? All of these things, huh? So there's a downside to this change. Okay, so what's broken? Cannot find summarize transcription. Did you mean summarize transcription task? No. Oh, that's funny. Okay, cool. That works. And now we can just be explicit about what we're passing in here, right? And it's happy. I don't know. Was that a worthwhile change? I don't know. I think that if we cared about the number of bytes in the file, which I don't, and it's silly too, I think that was kind of a wash. Yeah, I think I am going to say let's not do that. You know, at some point you just got to say, you know what, actually, let's just undo. Let's just undo all of it. It was not a worthwhile change. So let's just not. I could do this. I am referring to props dot whatever elsewhere. So we're just going to continue. Don't know what that was. We're just going to continue doing that. And we're going to say, hey, just go ahead and declare that property. It doesn't know how to use the imports that are there. There we go. All right. So that does it. Now, of course, now we have to thread that in, which means the other part of this change is that we remove stream ingestion step function from the props for task monitoring construct, because we don't need that. So that's all fine. We can actually remove another import here. And then, since we've removed the dependency in one direction, we're just changing the direction of the dependency, right? So instead of stream ingestion being a dependency of the task monitoring construct, it's the other way around. Like so. Now, do I want to do it this way? Right, so we're using task status lambda, and we've just moved this handful of lines of code over to here. That's what we've accomplished so far. Do I? Oh, it's a bot. Goodbye, bot. Do I want to? What do I want to do here? I could. Yep. Bye. I could make, instead of passing in the lambda, I could pass in the task monitoring construct. I could do that. And then it would have a method. I guess it would probably have a method that takes an rule target input. And so instead of constructing, so basically we've moved this, dozen lines or whatever over here. I want to move 2 lines back over to task monitoring. Right? So then we abstract away the idea that the task monitoring is a Lambda function. Like stream ingestion doesn't need to know that. It just needs to know that it needs to hook up a target. Now, a thing that, as far as I can tell, there isn't a good way to specify would be defining the... Actually, maybe there is. If instead of moving 2 lines of code, I move 4 lines of code. I'm highlighting 2 here, but the implication is the closing braces and parents. If I move this and I say the method on task monitoring takes a name, a status, and a time. Now those just have to be strings, unfortunately. But then we have a little bit more enforcement of the shape of the payload. I kind of like that. This is legitimately, this is like overthinking it, because now I'm the only one working on this. So this is just protecting my future self. But that's not a bad thing either. What does this look like? So if I were to change this, how would I change this? I would probably just change this to task monitoring. So task monitoring doesn't exist on stream ingestion. So instead we say, hey, this is task monitoring, and this is not a Lambda I function. This is a task monitoring construct. We just want to import this for the type. And now we have like an actual like module level dependency between these 2 things, right? So we have task monitoring, and then the way this is going to work is we're going to say, hey, add new target, task monitoring, props, task monitoring dot, there's going to be a new method, and that method is going to be, I don't think I want to make some kind of embedded class here. I think I just want a method on task monitoring because it'll have access to the Lambda. Because we saved the Lambda on this, right? So we saved it into the object that we're constructing in AppStack. So this has to be some method that we're calling because we need to pass in some things. Let me go cut this out. We can do something like new target. Maybe a little bit more explicit. New event target. What happened to the music? Why is it spinning? I don't like it spinning. Great. Let's see what's going to be a non-obnoxious station we can play really quick to maybe. Oh, no, it's resin. Okay, I want to just restart Pretzel. Gotta have music. If it loads. It's just broken. Could be. All right, so let's add that method. Interesting. It's gonna be public. I don't like new, but target. Well, we'll do this, and this is going to be void. Not void. It's gonna be something. We'll do this. Oh, hey, is it gonna work? It's thinking. What? Okay. Cool. Lots of complaints about something. I'm not even done. Yeah, here we go. Let's do this. Name, status, time. Yep. Okay. So you know those imports that I removed? Well, one we need back. That. And just make this. Status Lambda. We'll define these. These are just strings. And there we go. Now we have a method. A method that returns event target's Lambda function. But that is a rule target. So let's I don't want to close that. We're gonna say, hey, this returns an event's rule target. There we go. And so in stream ingestion, there we go. We just do this, and now we are not putting anything in stream ingestion about what under the hood how that event is being handled, right? It's just being delegated to our task monitoring construct to figure out. And that was a lot of work to get back to where we started. Pause there for a second, think about what we want to do next. Okay, so problems we need to solve. Problems. Problems. No, that's too many words. Sending pending for step functions that are not yet started. I think this next thing actually, the solution to the previous problem solves this one too, which is storing the type and ID. Or rather, not just storing. Getting and storing the type and ID of the record in the status table, right? So, like, I click the button in the UI, it starts stream ingestion. How do we know? How does this work? Are we gonna? Am I doing this in a way that's gonna make extra work for myself, right? So, like we have kind of natural events for the step function, or like its status. But what we need to do is when the step function starts, we need to send an event to our status, to task monitoring, that is like, hey, this happened. What does that look like? What does that look like? There's some possibilities. So, like, we can imagine that. Let's see. Let's fold a bunch of this up a little bit so we can get to the point. Let's just scroll. And all of this is just kind of like the definition of all the different things this does, but here's the chain, right? So chain, which is what we eventually return as the kind of the sequence of events that needs to happen. And yeah, so the first thing is setup state, and then get streamed from DynamoDB, list video objects, yada yada yada. So setup state happens. And this is just a pass step, right? So this just populates parameters. I think in this case, we're not going to have a pending status. I don't think so, right? Because unlike with the video uploads, which are in a queue, this process, the step function is either started or we haven't started it yet, but there's not a waiting to be started sort of situation with this. So I don't think we need to send a pending status, but we do want to push something into the record, which is the stream ID and the type. I think in other circumstances, we might have a process where we want to push the type and ID and say, oh, this is a pending task. I'm not sure exactly where we'll do that from, but we'll get there. So one thing I could do is I could add a step here that updates the task table in DynamoDB. Now, given I just spent like a bunch of time kind of like trying to not have the details of how this stuff works in these other processes, I'm disinclined to do that. It's messy enough as it is. Let's not make it worse. How do I do this then? I could. Let's check something really quick. When the step function is started, let's close that. When the step function is started, what is the event? Like when it's running? Oh, there is input. Interesting. but it's JSON. So if we wanted to, we could. That would not be good though. Let's not do that. Like we would have to. I don't know. I don't think that's a transformation we could do in our existing event mapping. And I wouldn't want to try to that. Yeah, you could in the Lambda parse the input from the details of the event, but that would be very specific to this one process. So I don't want to do that. I could have a task in the step function that emits an event, and then we listen for the event, and we use the existing stuff we've made to target our status update. Okay, so assuming we do that, right? So we add some. Let's imagine what this looks like. Const send start event. Sure. Copilot reading my mind. So what is it trying to do here? It's saying, hey, you can have an event task. You can have a task that's generating an event. We'll call it a stream ingestion start. And source is glowing telegram.stream ingestion. Just a made up string. The detail is there's a stream ID, and it's our stream ID. So you do something like that, right? If you did something like this, and then just put it into the flow. Then let's see here. Can we some of that? Then say, hey, let's make a const stream start event role. Let's see. So it's gonna hopefully regurgitate the thing that it already generated. Yeah, there you go. Go ahead and match. Oh no. We don't need that. We're making an event pattern. Yeah. So a couple of reasons why this doesn't work. One is that the name should be the name of the step function. Right, so wherever we did this. Interesting. What is JSON path format? All right, so the double curly braces are to escape them, and then yes, okay. So we are. Is there not a way to construct JSON with JSON toString? Does that work? Make an intrinsic JSON states that JSON toString expression during the execution of function state. Encode the given object into a JSON string. Let's go look at the docs. Double check that I'm doing this right. For JSON data manipulation, JSON to string takes one argument, which is the path that contains JSON data to return its unescaped string. The interpreter returns a string that contains JSON text representing the data specified path. Can we... Oh, it's the path that contains JSON data. Right. So that's not going to work. Because we'd first have to... Like, we need a pass step to build the state to use. So let's not do that. Instead, we'll go back to this. And then what I'm going to do is I'm going to say something like step function name. Yep. That's not what I'm looking for. Execution name. What is the definition? Return the execution name field from the context object. So theoretically, what we will do is we will push an event, we'll put an event that has the execution name, the step function. Yeah, let's call it execution name. That's what it is. Let's just call it name. Name and stream ID. So that'll be enough so that in our event handling code here, what we want to do is we want to grab name. I guess the status is just running. Time we have, but what we want to do is we want to add a new field called record ID. Yep. Record type. What did we say that it was going to be? It was going to be ingestion. Yeah, no, we haven't defined record type or record ID, so it's complaining about that. We'll need to add those and make them optional. But I think that works. So that means that when we have this data, we'll put it into the record. And when we don't have the data, this shouldn't remove data elements that are already there. So we're going to add record ID. Blah. Not a good comment. Record type. Can we get away with that? All right, we have to actually.
It's an idea, Uncle Ben.
Yeah. It contains strings returned from event field.from to substitute parts of the matched event. Okay. Yes. Yes, yes. Okay, okay, this makes sense. Okay, so I guess we definitely could include record type here as well. We don't have the record ID at this point, like when these things change, but that will ensure like the very first thing when the record is first created, it will be labeled with the correct type. What will be interesting is that implies that when we're loading the data into the front end, ultimately what we're trying to drive towards, right? We should be able to figure out some information, like not just an ID, but we should be able, because we'll have the task type and we'll have a record ID, and all of these things. Is it true that all these things will have a unique, will have an ID? What is interesting is specifically for the rendering task, it is one task that's given multiple IDs, right? Because of the nature of the process, it potentially, like, it's just gonna, something occurred to me, which is that if I trigger enough things, it's gonna try to run a batch job and it's gonna download like infinitely many gigabytes of video to run the process. And that's just occurred to me now. Also, oh my god. Got to open Discord before I started. Alright, so but that's neither here nor there. That's a future me problem. Today's problem. Could I just, I mean, at the end of the day, I don't want to have like these IDs showing here. Could I do something where I pull based on the, no, that's going to be, that's like every single type of thing I'll have to write back in code to fetch some specific data, right? If I can get to the point where I have the record ID and the record, like the process, like the task type. Ooh, actually, yeah. Hold on. Record type? No. Task type. Alright, what did that break? Did that consistently? Good. Well, sort of. Let's rename the other side. Task type. Task type. Let's just record type. Good. Okay. Right. So for the render one, it'll be interesting because the render will have multiple IDs for the rendering type. What do I want to do about that? Do I want... I don't know that I can do much about that right now. So, I mean, one, these types represent just like the how to get to the data element in the event rather than anything about the type of the data in the event. We're going to get that, though. We're going to pass it. Oh, yeah. So we've not talked about, we need to update the Lambda. Yes. Also, can I have word wrapping? There we go. So, we have status, time, created at, updated at, TTL. The other things are... record ID, task type. Very good. Then, yes, representing the idea that it is optional in the event. It may not be there. Record ID and task type. Sure. Then we just need to update the expression. So record ID equals if not exists record ID, right? So we don't ever allow overwriting the existing value during the update, nor the existing type. Okay, so I think that's good. Right, So the revisiting what the condition expression does here, I think this is just saying when the record is initially created, you're allowed to put whatever. Otherwise, you're only allowed to update the record if the status is running. So once we've left running, once we've left the running, where the race is over now. Once the status is no longer running, but it does exist, then it can be updated again. I don't know that that's. Why do we care? Why do we care? I don't know why I would care about that condition. And we're keeping the kind of task status information for 7 days before it disappears, which I think is fine. Okay, so this. What do I have unsaved over here? Do I have any unused imports? Okay. So this might work. Also, we don't need. This doesn't need to be public anymore. This can be private. Yay! All right. So I think this works. Shall we deploy it and see what happens? Why not? In the meantime, did our process that we ran... Oh, it failed. Interesting. Data limit exceeded. Wow. The state task DynamoDB returned a result with the size exceeding the maximum number of bytes service limit. I have never seen this. That is interesting. That is very interesting. So, I'm guessing, yeah, we don't even see the state output because it's too big. So this was DynamoDB get item, where key is the DynamoDB item key. So we're just retrieving the same thing, right? So we had the record, we kicked off a process, we wait for the process to complete, and then we retrieve the record again because the process would have updated the record, right? And so this is the, let's go over to metadata table. We'll query based on this key. What did we get and why? Okay. So this was we might need to restrain how much data we're pulling back. I'll have to look at that. So transcode. What's in here? Oh yeah, so here's the list of all the paths to all of the transcoded video files. Sure. The transcription. There are. Let's look at this in JSON view. And just normal JSON, if we can. No, we can't. Okay. How many lines is this? It's only 38,000 lines of JSON. It's the transcription of me talking. Oh, right. So this record pertains to one 20-minute segment. So here's all the words I said in a 20-minute segment. Is that what we're saying? Yeah, that makes sense. It's a lot of data. metadata. Yeah, so this is a normal like 20-minute video length. Transcode, yeah. Transcription, segments. Yeah, so the segments information is the big that appears to be, because it's like the detailed, like moment to moment. Like this is 30 seconds of transcript, right, with various stats from Whisper. It's so meta. Here is a transcript of me talking about the process, which we are now debugging. Yeah, anyway. Yeah, and then here's the, like, everything concatenated together with noise on the end. So it's too big. Okay, well we gotta troubleshoot that anyway. So in our deploy that we triggered, some things changed. Test monitoring status Lambda, we're removing these conditions. Right, so here we had permissions for event bridge to invoke the Lambda when the event came from the step function. I don't know why we removed batch terminate job from stream ingestion state machine role. Odd. Maybe we add it back in a different way. So now the status Lambda is invocable from, okay, basically the same thing, but now we also have this stream start event rule. Oh yeah, so right, because we moved where these are defined to a different construct, so that these are where they're defined is different. Okay, and then yeah, that's that permission again. Okay, cool, sure. This is not going to fix the problem we just encountered. We need to fix that. So that's in stream ingestion. Specifically, if we go to the step function, the task, the state task DynamoDB returned a result. DynamoDB get item. Oh, yeah, it's get. This is the thing that I'll be looking for in the source code. Get item from DynamoDB with this transcription, right? So we run the transcription process, and then we get the record after that. So that's this task. When we do that, we say, hey, give me the transcription and the metadata, and store it in DynamoDB. And then we call summarize transcription task, which passes some data. So it does in fact pass the segments, not just the concatenated thing. It does pass the raw segments to there, which is interesting. If we were not passing the data, like if we weren't using all the data, that would be easier. We'll just figure a way to filter it out before it comes back to the step function. I don't suppose. What is the limit, and why? Yeah, data limit exceeded. Oh yeah, there you go. States. function service is a limit for inputs and payloads of 256 kilobytes as UTF-8 encoded strings. So we exceeded that with the data that we're pulling here. So are we legitimately using segments? We also have text, which is smaller. Much smaller. Let's see. Let me think about that. So summarize. There we go. There's our. Here is the Rust code. Hey, we have Rust code. It's not all just TypeScript AWS stuff. All right. So this. You can see we have a struct modeling our transcription segment. That's our summarization input. What are we doing with that? Doing start.json toString of summarization input, which is this transcription. So we're reading payload.transcription and treating it is a vector of transcription segment. And apparently what we are doing is we are bundling up that array as JSON and sending it as a message to the chat completion API for OpenAI, which is fun. Apparently that's fine. It likes it. I wonder if it would be how different the process would be if I didn't do this and instead I sent the concatenated result, right? So not including the segment by segment. Now there is information in the segments that's not in the text, right? So there's nothing about like the timing of anything here. The segments, granted they have a bunch of like log prob, they have a bunch of numbers, but they also have like timing of when did this get uttered within the context of the video. Also it has tokens. That's fun. Alternatively, so what's the alternative? Well, generally speaking, with step functions, because the data that is being processed in the step function is limited, 256 kilobytes, as we found. What you do is that you store the data elsewhere, and you pass an ID to where it is, and the task retrieves the data. And why aren't we doing that here? We're doing that in other places. We do the other half of that where we like run the task and then we read the data out of DynamoDB. So why aren't we having it read the data from DynamoDB too? Why not? Why not? We have the DynamoDB client, and we must be using it to save. Yeah, we save the results. So why don't we retrieve the existing data from DynamoDB as well, instead of reading it from the input payload? Right? So here, this is, we have input key. That should be enough. Like we should be able to maybe just drop transcription and then read the transcription from DynamoDB. What if we did that? That's interesting. Hold on, it's got to think. We should be getting an error by removing that key from the request struct. That should cause an error. Why is it not? Oh, because Clippy's thinking. It's checking all all the crates. Okay, yeah, there we go. Okay, so if we do this, what are the implications? One thing before we do that, let me look at this Lambda function. So we're going to remove transcription here. Right, we're passing the key. That's the input key there. So let's remove the transcription. And then this Lambda function, let's take a look at this. This, yeah, where is that coming from? Oh, here we go. Okay. I just want to make sure that this is granted the right permissions. Video metadata table, read, write data. Yeah, of course. Okay, so it has the ability to read and write, not just like write. Okay, so that's good. So that segments. Where was the part where? Let me undo. Redo. Oh yeah. So transcription. Where are we? Reading the transcription from DynamoDB. Get item from DynamoDB with transcription. So the name will be a slight misnomer. Do we? Yeah, we're gonna remove this. So we're no longer going to be pulling the transcription out of DynamoDB. That's gonna fix our problem. But that will break things. But that's fine. We still need to do this because there's another thing that's happening here where we are pulling metadata from the record to use to keep track of elapsed time in the stream. So this is a bug I fixed the other day. At some point, our process was that as we're ingesting the overall stream, it finds all of the individual video records. It puts them in the right order, and it updates the individual video records with what was the offset in the overall stream that video record started at, so that when we are pulling the data together, we have that information. So there's some other places that we're expecting those that key with that timestamp to be there, or that offset rather, but the backend wasn't doing that, so I fixed that. So we still need this here to retrieve that metadata. So I guess this is actually get item from DynamoDB with metadata. Yeah, there you go. All right, cool. So that's that. So like we don't need transcription. We're not like reading. Transcription here is the initial prompt, so it's the transcription context, not the actual transcription. Yes, good. Okay. Now we just have to fix the code to work with the fact that we're not passing in the transcript. Right, so here we are expecting the payload to have the transcription. Instead, we need to get the transcript segments from DynamoDB. So transcription item, app context DynamoDB, get item, key should be that, send, await, sure, transcription item, item or something. Hold on, what is this? Sure. Output item or okay dot get. What is the type here? Transcription. And then wait, is it just this? we had some type issues, but apparently it's been another hour. Where does the time go? I'm gonna take a break here for a couple minutes, stretch my legs, and bring over some water, and I'll be back in 3 minutes. So